So, X as a service. Why buy the plant when when what you actually need is the outcome? We know that many businesses are looking for ways to reduce upfront capital, transfer performance and performance risk, and accelerate decarbonisation. And so that's why we see that models like cooling as a service, utilities as a service, heating as a service are attracting so much attention. So today's webinar will explore what these models look like and in practice, where they create value, and what they could mean for the future of industrial and commercial energy infrastructure. I'm joined here today by our membership manager, Mark Barber. Mark, how about I hand over to you to introduce a fantastic lineup of speakers?
Thank you, Jared. So we're very fortunate today to line up some great speakers for you folks. We have Eddie from Antora. We've got Mitchell and Matthew talking about a project at Visi, and we have Ian talking about cooling as a service project with Johnson Controls. Our first speaker will be Annie of Otfinoski. She is Business Development Manager for Antora, and he works closely with industrial companies to develop and deploy renewable process heat solutions, helping manufacturers replace fossil fuel heat with electrified systems delivered through innovative models such as heat as a service. So over to you, Annie.
Hello, Mark. Thank you. Thank you all for having me. Let me just share my screen. Okay. So Annie Otfinoski here with Antora Energy. I am leading business development in Australia for Antora. We are a US-based thermal battery storage company. We are backed by Grok Ventures, BHP, BlackRock, Shell, and others. And we are delivering zero emission heat at low cost, at scale, to industrial customers through heat as a service today. So this image you can see here is one of our projects that is doing just that in the US right now. So those white Lego boxes, those are our batteries. We have a modular approach so that we can scale with our customers and we have flexibility around site layout. You'll see that metal building with our logo. That is the boiler house. And then if you look behind it, that's our offtake customers. So we are selling them zero emission steam over the fence through their steam header. So this project is 50 megawatts thermal and it is multiple gigawatt hours. As you can see by the snow, this is a recent photo. This is in the Midwest. So the grid there has quite a bit of excess wind. So the interconnect that we got from the grid, it was over 100 megawatts that we interconnected, and we are procuring wind from the grid through a flexible structure. And we are selling the customer this zero emission steam. And so we have built out all of the necessary power infrastructure and we finance the entirety of this project, including all of that infrastructure, and built the project in under a year. And we are selling the customer steam at cost parity with natural gas. So this is an amazing success story, and we're really proud of this project. And we have a lot of learnings and successes from this model, heat as a service, that we are very excited to bring to Australia. So we believe that this is the right market to continue developing projects similar to this one. Heat as a service is our core business offering because we believe it is the fastest path to thermal decarbonization, and it offers the lowest risk to off-takers. So the biggest barrier is most often CapEx. So heat as a service offers zero CapEx. As you can imagine, a 100 megawatt interconnect is quite a bit of infrastructure. There was a whole substation, transmission lines, and so that adds a lot of CapEx for a project. It's not just necessarily the utilise system, it's everything that goes into it. So we take care of all of that. We take care of all of the maintenance, ongoing maintenance costs as well. And then our solution is a drop-in seamless solution. So as you saw in those photos, we are adjacent to our customers' plants. It can be just nearby. We are just sending the steam through the steam header, so we're not integrating into the plant's processes directly. So drop-in solution. And we are competitive with natural gas. So we match the price of natural gas that the customer would have paid, or we often offer discounts to the price of natural gas. So we do this by charging our batteries with low cost power. So we are incredibly flexible on when we charge. So we charge at the lowest hours of the day when there's intermittent renewable energy on the grid, or we can directly connect to a renewable asset. So we charge up carbon blocks and we store that energy in the form of heat up to 1500 degrees Celsius for multiple days while delivering continuous heat to industrial off-takers. We use carbon as our storage medium because it is 4 times as energy dense as electrochemical batteries, and it is 1/10 the cost of lithium ion. It also is incredibly strong. Its lifespan is 30 plus years, and the carbon actually gets stronger with heat over time, so it doesn't degrade. Our current product is Heat Core. Heat Core can deliver hot air up to 360 degrees Celsius and saturated steam up to 300 degrees Celsius, superheated steam up to 360 at 80 bar. We have multiple day duration, and we're charging typically at a 3-to-1 ratio and have some flexibility around that. And then, as I mentioned, long lifespan, 20 plus years. So this is why we're all here today. Heat as a service. So I've mentioned multiple times, no upfront investment required from the customer. That is the core of the agreement here. There's no CapEx, and we take care of all of the power procurement. We set up our own separate service, and then we do all of the project development, installation. We come in and we are going to match what you would have paid for natural gas or offer a discount if possible. And the mechanism for how we do that is very flexible. Depends obviously on every plant, but we will work with our customers to find the best mechanism to do just that. We take care of all of the ongoing maintenance. And so ultimately, we view this as very low risk to the customer. So we are coming in and we are offering optionality. So our system is right there offering zero emission steam, and the customer will keep their natural gas fired boilers for redundancy. So that offers kind of a hedge for the customer. So we believe that electricity markets are going to continue to have low pricing available for us to charge our batteries. But we understand that energy markets are changing and there's obviously risk there, and we take all of that on. And the customer still has the option of using their natural gas boilers. So instead of locking in on a technology where you're only locked into energy prices for the long term, if you electrify, or you're locked into natural gas prices, this gives you the optionality and some hedging capability. We believe that there's a lot of reasons to have zero emission steam over the lifetime of a project with us. Different carbon markets are going to open up, and electricity markets and energy markets shift and change. And this is an electrified zero emission steam option that you can have at your plant with zero CapEx. So we are 300 plus in the US, and now we have established an office in Australia. We're in Sydney, and we are very excited to build out a team here in Australia, and we're very happy to be partnering with organizations like A2EP and gaining that local boots on the ground team and expertise. We're very excited to be here. I'm based in the US, but I am here in Sydney and around. I'm traveling quite a bit all over the country for the next few weeks. So I would love to meet with you. If you are an industrial heat user, I would be very keen to learn about your plant. I'd love to go visit as many plants as possible. I'd love to hear how we can support you on your decarbonization journey. And I will be back and forth. And again, we're building a team here. So we're here to stay. We're very happy to be here. And we believe that Heat as a Service is going to be successful in the Australian market. So please reach out and thanks for having me.
Good one. Thank you, Annie. Compelling offer. A couple of questions, and then Mark will see if we'll squeeze in one of the Q&A, one or two of the Q&A questions there. Uh, New projects. We know that energy efficiency and certain amounts of good capital is not available for new projects. They run out of capital. Let's get the bare minimum. Let's get this factory running. Is this sort of heating a service available for brand new
Yes.
developments?
Yes,
Yep.
absolutely.
Good.
Yes.
Okay. Could help a lot. And second part then, a question I'm wondering about is the modeling. We did a webinar just recently and showed the modeling for a site to work out the size of the equipment and what have you. First of all, requires a lot of data, and secondly, a fair bit of insight for how to do that. Where does Antora come in and how do they deliver that?
Yeah. Jared, are you speaking to when you say the size and the expertise required, do you mean just around the power, I
Yeah, and in
assume?
terms
Yeah.
of do I need should I get a 10 megawatt plant with 80 megawatt hours of storage or should that be 20 and 80? Yeah.
Oh, sizing for the
Mm,
plant specific heat needs. I
mm,
mean, we take care of all of that. You just tell me what your steam demand is, and we will size the system to meet that, and even give you some buffer if you increase capacity over time and you need more steam.
gotcha. Thank you. A few questions there, Mark.
Yeah, so Chris Fox raises a question. What is your typical cost of finance and how do you keep it lower than, say, a large multinational's international finance costs?
I can't I can't speak to that exactly since, we keep a lot of CapEx figures and all of those finance details a little bit closed just because we offer heat as a service. But it's good. It's great.
And Gary Rosengarten asked the question with regarding air output temperature, why is the output limited to 360 degrees?
We could get higher. So I mentioned that the actual core of the battery gets up to 1500 degrees Celsius. It's the integration of some of the equipment that's actually delivering on the output is limited. We use a heat transfer fluid that is going to, well, I guess that wouldn't be for the hot air. But we could design our systems to go up to higher temperatures, and that is for our future product, which is Heat Max, which will be able to deliver heat at higher temperatures. The delivery needs to be more integrated with the plant. And so there's quite a bit more engineering involved, and we have to be more integrated into the plant. So that will come later. And we're looking forward to partnering with steel, cement, and higher temperature industries to engineer those battery systems to fit their plant needs exactly. At this time, we're looking for a more drop-in seamless solution. So we're focusing on that low to mid-range temperature, which is a bulk of customers.
Good one. Got a few more questions. Maybe Annie might like to answer a few questions there in the Q&A box, and
Oh, okay.
we'll keep on moving. And if we get to them at the end, we'll come back to them and go through them as well, I think. Good.
Yeah, thanks, Andy. Inspiring stuff. The next project is also quite inspiring and innovative in the Australian context. We're going to hear about a compressed air project at Visi's Atlas site, which has been in place for about a year. presenting that project will be jointly between Mitchell Vickers and Matt Smith. Mitchell is the site services manager at that site. He's got 15 years in experience in various roles across a variety of industrial sites, including Asahi, Rio Tinto, and now with Visy. Mitchell's responsible for the reliable and efficient operation of Visy's plant services, including the all-important compressed air. Matt also brings 15 years experience delivering energy productivity projects to Australia's largest energy users. Projects are delivered with a fixed price and energy savings guarantee, providing clients with a predictable OPEX savings and a co-benefit of carbon reduction. So over to you guys to tell us about it.
Yeah, sure. Thanks, Mark. We're going to be sort of co-presenting, so I'll let Mitchell sort of kick off first, and then I'll take it sort of halfway through. So over to you, Mitchell.
Thanks, Mark, and thanks, Matt. Hi, everyone. Speaking to you from Visy's beverage can site at Yatala, as Mark mentioned. Real quick, Visy has 4 beverage can sites across Australia and New Zealand. Output for our Yatala site is approximately 582 million cans. And obviously, to appreciate, compressed air is very, very important part of that process. The project that we're going to talk about is approximately 12 months old. We've just had our 12-month review. And within Visy, it's the first as-a-service model that we've attempted in any business arm. I'm sure you know there's quite a few different business arms within the Visy empire. And I believe it's one of the first air as a service. I know we've touched on heat and cooling, but one of the first air as a service, I believe, in definitely Southeast Queensland. So there's a little bit of data you can see there on the screen. A bit of background on what we had prior to the system. Obviously, our core business is manufacturing beverage cans. Our previous system was not fit for purpose. It took a lot of distraction away from our maintenance staff and production staff. Obviously, we want them to be focusing on manufacturing those beverage cans. We had 2 fixed speed oil injected compressors and 1 VSD. Not really ideal for what we need. There was no load sharing. They were air cooled, so obviously they put out a lot of heat, which is not ideal for our application. We're running on a lot of low pressure components that were throttled down high pressure, so obviously, as you'd appreciate, extremely inefficient. Basically, the system that we have now was a complete rethink. You can see the data there. We've achieved 37% energy savings with this new system, and complementing that, 3 ultimate oil-free compressors, so a big change from our old oil guzzlers of the past, and they're water cooled, so we have no ambient heat going back out into the factory at all, so that makes it a lot more pleasant for our team here within the factory. And we've split the system up, so there's a high pressure and a low pressure. So through this process, we identified some components on site that could be supplied by a low pressure system. So we've got 2 dedicated compressors to that. And quite recently, we've potentially identified another bit of equipment that can be supplied directly by the low pressure, which is currently on high pressure. So that's a potential unlock moving forward 12 months in. And a big key feature there, second from the bottom there, is we can actually spill between those 2 sides. So if we do have a breakdown or an issue with the low pressure side, we can actually spill over our high pressure supply into that system through the use of quite a fancy electronically controlled valve. So that gives us additional redundancy within that system as well. So that's a real winner for us here on site. We now have redundancy within our system, and we have stable, suitable dry air, which is fit for our purpose here. We have had a lot of trouble with dew point on our old system, and that has pretty much become null and void with this new system. So we're getting the air we need at a temperature we need and a quality we need across the board. All of this is controlled by a SAM, which Climatech installed as part of the process. So that lives on the wall there. It basically, in parallel, runs the high pressure and the low pressure, and sends needs and brings demand on the compressors as needed, which has taken away any need for anyone on site other than myself in a monitoring capacity to have any interaction with the system itself. So we've gone from having maintenance staff, after hours, production staff having to attend to compressor issues, to having no one have to have any interaction with the compressors. So it's taken a lot of distraction away, and it's allowed us to, as I touched on before, focus on our core activity on site, manufacturing beverage cans. Big one there, the 37% energy saving has been a real winner for us on site. Moving on. So basically, as you can see there on the left, we at Visy provide those things there: water, network connection, air, drainage, which is a fancy way to say where we can put our waste. Not that there's a lot of waste from the system. Obviously, electricity and the building. Everything Climatech there supplies, obviously, is within the confines of our factory. We've got a little bit of a footprint in our MCC and network room the guys have tapped into. But by and large, it's been little to no interruption to site activity. We haven't engrossed in terms of footprint into the production area. We haven't taken up any necessary space within our control room. And actual fact, just on impact to production, we tied in our low pressure side system with a planned 4 hours interruption to production output. We'd allowed for 6, so we had a win there. And we did the major tie-in of the high pressure side. We allowed a 32-hour window, and we had that done within 18. So minimal impact to production on a number of fronts, but obviously with those outages, they were a real win to get them done in those minimal timeframes. Moving on there. Biggest thing for us, our budget certainty. You can see that there on the top line. With the model that we've got with Climatech, we can forecast ahead with the data we have to know what our charges will be in line with our air usage. That's quite a contrast to our previous old in-house system. It was, due to the nature of the equipment, it was very ad hoc and very erratic when it came to maintenance breakdowns and that sort of thing. So we've got a lot of stability in that space, which has made things a lot more palatable for us here at site. Last thing I want to touch on down there, obviously I've mentioned core business. The real big winner for us has obviously been that just the takeaway. Our core business is beverage cans and supplying our customers. This partnership with Climatech has allowed us to really put both eyes back on that in terms of having to worry about intermittent air supply, quality of air, reliability of our previous system. That's been the real, apart from the monetary benefits, that's been the big win for us. We can have our production staff focusing on production, and maintenance staff focusing on more effective, more value-adding tasks. And we've obviously had a gain in our performance in our equipment due to the higher quality of air. So it's ticked quite a few boxes along the way. As I said, we're 12 months in. From a site point of view, we're extremely happy with where we're at so far.
Thanks, Mitchell. I've got a couple of slides here just from the Climatech Zero side in sort of general. So I guess there's some pros and cons, and you can do different things. So for some sites, it might be that they want an energy performance contract and they're not as interested in utilities as a service. But I guess what we're talking about today is all the benefits that you can have if you did choose to go down the utilities as a service route. And the example that we're sort of going through today is compressed air, but it can be done for heating, cooling, hot water systems, steam systems, whatever you sort of like. So as part of the utilities as a service, like Climatech Zero would be the key point and single point of responsibility. And we have no sort of split objectives because when we deliver an as a service project, we're responsible for the uptime as well as the energy performance, as well as, basically owning and operating, servicing and maintaining that asset for the lifetime of the asset. And obviously there's a bit of flexibility on what time period you might want your agreement for. But because the utilities as a service is us taking ownership for that whole lifetime, we're optimizing to give the lowest cost of that utility over the entire lifetime of the asset. and we're optimizing based on that. And in a traditional sense, you might have a design team that would do the design of a system, and then a different company that might deliver the project, and then a different company again that might do the ongoing service and maintenance, and they might be optimizing for different things. You might end up with a project that gets delivered to a maintenance company, and the maintenance company says, this is horrible to service and maintain. Why is it being sort of built like this? And so because everything's all through one party, we're optimizing for the entire lifetime of the asset. So with just the model in general, it has a very good alignment between sort of what's best for the customer. So I think it adds a lot of value in that sense. Another thing, like the ideal scenario for utilities as a service would be if you have any significant energy use assets on site that are coming, not falling over yet, but coming to end of life, where perhaps you're speaking to the finance team already about there's some upcoming capex going to be coming down the line because we know these systems at end of life. That's the perfect time to start looking and doing the engineering works for utilities as a service, because quite often you might end up with a like-for-like replacement on your equipment on site, where there may be an opportunity for significant energy savings and a utilities as a service option that would then leave you with no money down, and that capex that you've been planning for to spend can be used elsewhere. So that's always the best sort of target, is if you have any upcoming significant energy users coming towards end of life. That's a great place to start the conversation. So just a little bit around, sort of Climatech Zero versus the customer. So we'll take on the complete risk of running the asset, including sort of failure. And because we're responsible for that and we are taking on risk, we have a lot of redundancy in the system, because if something breaks down, we want to know about it immediately. So we have a lot of on-site monitoring as well. And also the redundancy allows the system to keep running while we send someone to site to fix it or discover what the problem is. And so from the site's perspective, they might not even know that something has gone wrong. We've already fixed it and the redundancy kicked in and it kept running the whole time. And that's just all part of the design. So there'll be also some damages that we'll pay that can be agreed on sort of a case-by-case basis if there's downtime. We are responsible for replacing any failed equipment as well as service and maintenance. And because we're actually paying for the electricity that's coming into the system for the compressed air system, we're incentivized to run it as efficiently as possible. So there's like the way the structure is set up is that we're going to run this utility as efficiently as we can for the lifetime of this as a service agreement. Because of the way that it's structured, we're incentivized to do it as such. And then from the site perspective, I think Mitchell did a great job of going through the pros and cons on site and the benefits that they're seeing. But yeah, they're basically able to use the air as and when they want and when they need, and it's our responsibility just to make sure it's there and at the quality that we've agreed on for them to use it in their production system, and allow them to basically put both eyes back on what they do best, which is the production on site. We might have a little bit of a back and forth with Mitchell here, but one of the things that we provide to utilities as a service customers is sort of we'll connect into their on-site data. And so here's just a screenshot from, and you can see there, in the green is the total airflow. The baseline model power is sort of the model that we built on what energy they would be using if we hadn't done the upgrade, which is the top blue line. And then we're also measuring the current plant power in purple for the compressed air system. And so as we sort of showed earlier, it's like approximately 37% energy saving across the system. But this type of information is available live to the customer. So you can log in at any point and, depending on how quickly the data points are coming in, you can just see how your savings are going in near real time. Is there anything, I guess, that you wanted to add there, Mitchell?
It was actually just, with this pre-monitoring, it was links into a question that was put to Annie. We had Steve and some other members of the Climatech team on site gathering that baseline for a good, I think it was almost 6 months prior to commencement of the project. So that was a real benefit for us to actually capture how a beverage can site uses compressed air. It's a little bit different to most probably other high-speed manufacturing situations. So we really put the time in from both sides, a Visi side and a Climatech side, to gather that data and get that baseline. And I think as a result, you can see there the results speak for themselves, that the hard work we put in to get that baseline has given us the the result with the improvement there, as you can see.
Cool. Yeah, and I just see a question come through from John in the chat there. Yeah, so Climatech Zero is accredited for VEECs and ESCIs. And so if there is, for example, you have a site in New South Wales or Victoria, or you want to claim ACCUs, then we can claim those certificates as part of the project, just to help the commercials overall. So that's something that we do just for every project that we deliver. And I guess this is, just the summary before and after energy use. And if anyone wants to just have a conversation or contact, please let me know.
Good one. Matt Mitchell, great story. Good results. Well done. Maybe I'll kick off with a question or two that are you watching closely when Compare or others come on site to do the service? In A2EP's work in the past with compressed air, we did get quite a few stories to say that when the OEM comes on site to, doing their training and they're servicing the equipment as they're trained, but that can result in some higher energy costs afterwards. And conversely as well, sometimes it comes back and says, oh, this service went really well and we can see the better performance. Have you experienced that, either of those for the moment?
I can speak to that first, and then if you want to jump in, Mitchell, at the end. Yeah, so because obviously we have all this risk that we're taking on as part of utilities as a service, and also we've got the incentive to run the utility as efficiently as possible, we have a lot of data coming off of that system. And so, we've got live monitoring, on pressures, flows, electrical consumption. We can see what each compressor is doing individually or the system as a whole. We also have a camera feed just to the system itself only, so we can actually get any visual clues around if something's not running properly or there might be an issue on site. Perhaps, you start seeing some water or whatever it might be. And we also have some checks that we run daily and weekly and monthly. And so there's someone who's logging in, having a look. We've built some daily, weekly, monthly dashboards with the right data that we want to look at on the regular cadence, just so we can get on top of anything that might be trending away from, perhaps the energy performance is dropping, or there could be some early warning signs around, something getting too hot or whatever it might be, and just get on top of it early, really.
Good to hear. Mark, we've got a few questions there.
Yes, just getting through those. So one question, are there tax implications after the term of the agreement expires, and who owns the plant upon termination of the as a service contract? I guess that could apply to both projects we've been talking about.
Yeah, there's definitely, I won't pretend to be any expert on the tax implications of this, but we can definitely do a follow-up if anyone has, sort of explicit questions around their individual case. But yeah, so there's ownership is currently sits with sort of Climatech Zero and whoever might be leasing or owning the asset during the utilities as a service portion of the project. And then at the end of that term, it can get handed over back to the customer.
Okay. Some more questions there, I think. Jared, do you want to pick one?
I think we had a question about liquidated damages, and Matt nicely, timely came in with the slide to say, yes, we do take liquidated damages there. And I guess that's, we're not going to hit you for an exact sum there, Matt, but I'm sure that's a case by case. But so it sounds like you're putting your money where your mouth is, though.
Yeah, that's the idea. Obviously, yeah, as I mentioned, case by case sort of basis around, what's discussed with the client around what they see as reasonable and what we see as reasonable. Yeah.
I've got a question around the compressed air. So obviously the other part of the equation in terms of minimising the cost of that service is managing air leaks in the reticulation systems through the plant. So is there a clear demarcation in that regard, Matt, or do you collaborate with Visi also around air leaks, for example, by giving them intel or insight through metering?
Yeah, the way that the structure of the as a service is set up is that if they wanted to manage some air leaks and make some air savings, that's totally fine. It's not going to sort of affect the agreement in any way. And currently, we don't have a specific agreement on that site for managing the air leaks regularly. However, that's something that we could do and discuss. But yeah, just in terms of, is it going to affect the contract for utilities as a service specifically for compressed air? No, that's fine. It's fine for you to go and reduce the demand side.
So I might go one more question there before we move on. There from Satinder about what about for existing plant at existing site there, Matt? Is that you'll take over that, or do you have to say no? We need to put new equipment in there.
I think we'd probably say that it's a case by case basis. You know, if that was something that was we understood was like maybe new equipment and we had an understanding of what was running, or we saw it as low risk. Because essentially, as long as we're happy to take on board that risk transfer when we when we convert maybe it's existing equipment into, hey, we'll take that on, we'll own, operate, service, and maintain it. If we see that risk as manageable, then we could look to do an existing equipment utilities as a service. But yeah, that would just be on a case by case basis.
And we've actually done that with this project. We actually took the VSD compressor that we had previously that was deemed to be in a suitable condition, and it's now our backup for the system on the high pressure side.
Good one. And a final one there for you, Mitchell. How, if you didn't have this outsourcing type option, how would you have had resources to look at it in such detail and get the performance there?
We probably wouldn't have, from an in-house point of view. It would have been a real struggle. Like I said, all of our resources were being dragged away to the pre-existing system, and obviously our expertise is not in compressed air or compressed air systems. So we would have, made it through, but it wouldn't have been to the extent, not with doing this project with Climatech.
Yeah. Thank you.
Right. Rightio. So, yes, inspiring stuff again. And in keeping with the theme of having great speakers, we now have Ian Premak talking from Johnson Controls. Ian leads the sustainable infrastructure for Australia and New Zealand at Johnson Controls. He's got 16 years experience delivering outcome-based infrastructure projects globally. He specialises in energy as a service models that help organisations modernise assets and improve energy performance. Ian has closed more than $150 million US dollars in projects across the Southeast Asia and Australia regions. Over to you, Ian.
Very good. Thanks, Mark. So good afternoon, everyone, and many thanks for letting me come and present today on behalf of Johnson Controls. For those who haven't met me before, I am Ian Premak, and I am the sales leader of our sustainable infrastructure business in Pacific, which is Australia and New Zealand. I'm based here in Sydney, and as Mark said, I'm responsible for originating, developing, and closing complex outcome-based deals, specializing in energy as a service and infrastructure as a service. So today I'll give you a quick introduction on what we do at Johnson Controls and what I do as part of the sustainable infrastructure team. Then I'll talk a bit about how performance-based procurement models transfer risk to the service provider, including an overview of how energy as a service and infrastructure as a service work. Then we'll discuss what we've done, and I'll share one commercial and one industrial case study that I've personally been involved with, following by some of the lessons learned and key takeaways. So first, what do we do? So some of you might be familiar with what we do at Johnson Controls and the brands that we have, and you'll know that we have the world's largest portfolio of building technologies, software, and services, things like HVAC, BMS, security, fire, and digital solutions. And as part of the sustainable infrastructure team, we deliver infrastructure outcomes in the built environment through innovative deal structures with risk transfer models. And really what we do is we solve business challenges. So it could be ones like Annie and Matt also said before around capital constraints, energy, operational spend, skilled labor shortages, for example, that Mitchell was talking about, and decarbonization mandates. And really what we do is we're aligning these infrastructure requirements with the financial outcomes through innovative commercial models. And the best part of all is that we'll guarantee these outcomes for the entire contract, backing ourselves with the financial penalties for non-performance. So how do we do it? Well, as Matt was saying before, you've got the traditional model where really the owner is responsible for choosing the design team, the contractors, the equipment, the technology, and having the in-house operations staff. It's quite familiar, traditional, everyone knows how to do it, and it really just gets value engineered to the lowest first cost to an approved budget. But the owner ends up just holding most of the risk. Then if you look at the right, the performance-based model, the owner could reduce the risk and responsibility by choosing the right partner and leveraging the risk models. The service provider is able to then take a lot of these on. You can see in the light blue bar, we've got design, install and commissioning, operations, service and maintenance, performance risk, lifecycle risk, and even the financing. They're all taken on by the service provider, whereas the owner really is just responsible for the monthly service repayment, the utility commodity cost, and the utility availability. And there are several different procurement models which can be used depending on what the owner's goals and the business challenges are. And you can see those at the bottom of the slide. That could be anything from performance contracts to energy as a service, infrastructure as a service, decarb as a service, where we would guarantee your scope 1 and scope 2 net zero emissions over a period of time, aligned with your mandates. And then lastly, buildings as a service, which is quite familiar in the PPP space. So as you heard from Annie and Matt earlier, there's several key benefits of the as a service model, such as the no upfront capital, the energy savings, and the total cost of ownership. But in addition to that, there's quite a few that are also available that haven't really been discussed today. So the first one is really on the facility condition, or handback as it's known. And so at the end of the term, the client will then get an asset back transferred to them in good working condition, which is obviously a benefit for them and provides the assurance that they're going to get a working plant. There's also the potential for off-balance sheet accounting treatment. So with the energy as a service model, that is typically owned by the service provider, and that is off-balance sheet of the customer. And where Matt and Mitchell were talking about before, that's more of a fixed repayment structure, potentially on the Visi balance sheet. Depending on how you want to structure the deal and what financial outcomes you require, that's something that's worth considering. So what is the structural overview of this energy as a service and infrastructure as a service? Well, really the framework of the two is the same, and I'll explain what the differences are in a moment. But really it's JCI taking on the design and build and ownership of the infrastructure, removing the capital costs of the project. We'll finance it and or own it, and we'll either do that directly or indirectly with potentially a third-party financer. We'll then take on the responsibility of the operations and maintenance risk, including the life cycle of replacement of all those various components throughout the length of the term. And we'll provide the services for the recovery of capital, construction, and the O&M over the term. And the payments, the service repayments as they're called, are really just subject to KPIs that provide for outcome-based payment. So if we don't perform, the customer doesn't have to pay in full. And that's really where the difference comes between energy as a service and infrastructure as a service. So with energy as a service, the client is paying for a form of energy being produced. That could be the chilled water, it could be hot water, it could be electricity, compressed air, and it's generally paid per use in a consumption-based model, and is treated either partially or fully off the customer's balance sheet. Meanwhile, with infrastructure as a service, it's extended out to other technologies and infrastructure on the project, which is generally a fixed service repayment. We'll dig into that further on the next slide. So as you heard before, there's various components that make up the core infrastructure that are either going to produce this heat or produce this compressed air. And while energy as a service does that for the core infrastructure for, say, cooling or heating, there's other infrastructure that could be built in. We know a lot of our customers have some broader project goals. They could be building a brand new building. They could be doing a broader retrofit of an existing plant. And let's say they need to upgrade the fire system or the security system, something along those lines. Well, that could all be bundled in together into an infrastructure as a service project, which will then reduce the amount of capital required for the client in the long term, achieving larger outcomes. Now, on the right side, you could see that it's quite flexible in terms of how the performance risks, the payments, and the ownership works. So with the risk guarantee, it all comes down to KPIs. That could be units of energy saved. It could be carbon emission reductions. We have uptime and availability guarantees. Could be condition of chilled water supply temp, for example, you name it. Flexible payments, so it could either be fixed or variable, or even completely variable, if that's going to be an energy as a service model. And as I said before, we'll put our neck on the line. So if we don't perform, then the payments don't have to be paid in full. And then lastly, we're agnostic to ownership. So if the client wants to own the asset, or if they want it off their balance sheet, we could work with you on the right structure to make that happen. So as you can see, these as a service models are incredibly flexible. So it's important you understand the business problems you're trying to solve and align the contracting structure to suit. So as you can imagine from what I just talked about, there's a wide range of industries and applications where these as a service models could work. And you'll see it all across the globe from what Annie was talking about in the US, versus what I personally experienced in APAC and here in Australia. So today I'll be talking about two different case studies that I was personally involved with. This first one here is a commercial project, commercial redevelopment in Singapore. And the second one will be an infrastructure as a service project in the mining sector in Australia. So on this commercial project, it's a redevelopment in Singapore, planned to open in 2028. And it's going to be the first end-to-end carbon neutral development from design to construction to operations. So sustainability is top of mind. And as part of the project, the client is looking to achieve BCA Green Mark Platinum Zero Energy, which for us in Australia is equivalent to neighbors, let's say, a very high neighbor score. And they're looking to achieve a 50% energy savings compared to the 2021 Green Mark baseline. Specifically for the chiller plant, they're looking for an efficiency of 0.465 kW per ton annual average system efficiency, which is very, very efficient using a mixed loop of high temp and low temp chillers. And through the origination development stage, they've ultimately decided to call a tender, and they put it out to the market with a select group of partners to pursue it. What we ended up providing was a 20-year energy as a service structure, specifically cooling as a service, where we're providing chilled water as that utility. And we as XaaS Controls, we obviously are the OEM of the chillers and the BMS. And we also have our digital platform called OpenBlue. And we're using third-party materials like pumps and cooling towers to ultimately complete the system. And we're doing the full design, build, operation, and maintenance of it. Now, there's a lot of risk transfer in this one in terms of KPIs and guarantees, but the main one is around this BCA Green Mark Platinum. And now the client can then definitively go to the market and to their future tenants and say, yes, we are going to have Green Mark certification. And they could say that because we are taking on some of that risk. Lastly, there are penalties and service credits provided back to the client for non-performance. Now moving over to the Australian project. So this one is for a copper mine. So it's an Australian resource company. And this client is a large Australian gold and copper mining company. And this project was based up in Queensland. And on this one, it's a slightly different challenge. They were committing to having the mine cooling plant operational back in October 24. And ownership of the plant would have triggered their capital projects approval process. And based on the timeline they were looking at and that approval process, they would have missed the budget, missed the deadline, by quite a bit. However, they did have OpEx budget that was available, and they're ready to use that, and that would have sped up the approval process. So through our XaaS Controls Capital, which is our financing arm, as well as our Gordon Brothers Industries business, we're able to provide a full design, build, finance, and maintain turnkey engineered solution for the client, which covered the plant with the option to own the plant at the end of the term. And we committed as part of that project to have the plant installed by the date, which was a KPI. And we, again, provided similar infrastructure as part of that plant using York chillers and pumps and cooling towers, bulk air coolers, and our OpenBlue digital solution. Now, on this one, it was a much simpler structure and a 4-year term, but no capital outlay by the client. And they were able to repay it using OpEx budget they've had allocated. And of course, at the end of the term, they've got that full flexibility with the option to buy. So a big win for the client in that sense. And then to top it off, the engineered solution that we put forward provided significant energy and water reduction savings. And overall, it was a 30% OpEx savings versus a traditional plant. So it allowed the client to focus on their core business while we were able to take on some of the KPIs around uptime, availability, and temperature. And lastly, so just to share some lessons learned and key takeaways for those that are interested in as a service. The first one is that as a service procurement requires a coordinated team effort. It is definitely a complex project that involves many stakeholders from both your organization and ours. And my personal advice would be to involve those from your finance team, technical accounting, and operations team from the start. Many of us on this call come from a technical background, and we've had many instances where we've had what we thought was the right technical solution, but things didn't get implemented because of financial reasons and the business case associated with it. So leveraging these as a service models could help solve that if you get the right people in place up front. Start with the end in mind. So understand the business problem that you're trying to solve, then align the infrastructure with the financial outcomes to determine the contracting structure. Appropriate risk transfer is key. I talked about some of the KPIs and the service level agreements, but we'd have to work together to determine what is the risk that you want to transfer, what is the quantity of that risk, because every risk has a cost. And of course, the KPIs and the penalties for the non-compliance should be fair and reasonable and worked out mutually as early as possible. For those that were asking around the benefit, the cost benefit of this, so we've had clients do their own investigation analysis on this. And generally, the infrastructure as a service and the energy as a service models provide about 10 to 15% savings in total cost of ownership over a 20-year term. And last but not least, while not every project or client is suitable for energy as a service or infrastructure as a service, there are certainly innovative models out there in the market that could solve your infrastructure and decarbonization challenges. So feel free to reach out to any of our experts today, and we could talk through how to solve those with you.
Good
Thank you
one.
very much.
Thanks, Ian. Looks like plenty of quite a broad offering there, and lots of different ways to put that together. One small clarification there. You mentioned one of the slides that stays with the risk of the owner, and you describe it as in there. It says utility availability. That almost implies like equipment availability, utility availability. Is that like availability of electricity to supply that?
Yeah, great.
Yep.
Yeah, great question. Yeah, good to clarify that. So in a cooling as a service example, the output is chilled water, right? So for those that are familiar with mechanical plant, in order to operate a chiller plant, you need to have electricity coming in and you need to have makeup water for your cooling towers. So the water utility and electrical utility going into the building or coming up to the plant is what is the requirement of the client. But ultimately, the rest of it is on us, right? The scope and the boundary of the chiller plant is on us, and we'll produce the chilled water, and we take on that uptime and availability risk.
Gotcha. And you mentioned right at the end there, sort of that it's not suitable for everyone, every client, but is it possible to say, hey, these are the more likely scenarios? A company is going through a lot of growth, they're capital constrained. You had capital constraints for that one for the mine site there.
Yeah.
How can you put that into terms of say, okay, you're more likely to need this if you're X?
Yeah, for sure. So generally what you see is that the energy as a service or infrastructure as a service structures are larger dollar projects. So as a very generic rule of thumb, most of these usually around $10 million or above. You could probably do it a little bit smaller in terms of the capex of the project, but that isn't a necessary deal breaker because we're able to fund projects that are generally $100,000 or above. But you would use a different finance and commercial structure in order to solve that problem. You just wouldn't be able to do everything and charge it, say, on a pay-per-use energy as a service model because there's so many development fees that go into the actual costing of the structure and the project itself. We mentioned before around a lot of the upfront engineering work, some of the legal fees, these are bespoke contracts, for example. So all of that needs to be rolled in. But that being said, a design, build, finance, maintain project is one and the same regardless of size. So if you have capital constraints, you could solve that problem.
Mark, we've got a few questions coming through.
Yeah, going back to Antora's presentation, there's a question here from Chris Laurie, and I think he's basically asking what the sweet spot is or the ideal range of system capacity that you're aiming at.
Yes.
Or targeting. Yeah.
Hi. So we're looking for 20 megawatts plus thermal load.
So the big ones, big end of town. There's plenty of that size.
Yeah. Yeah.
Good.
And there's another, and while you're talking, Andy, there's another question here, which basically is, I think, seeking some clarity around what happens in your scenario if the electricity price goes up a lot more than you expected.
Yeah, that's a great question. So we would have the customer have the option of either having steam with a green premium in those instances or operating their natural gas boilers.
Right.
Okay. So might need both systems in place.
Yeah, we wouldn't want customers to just take out their natural gas fired boilers. So they would keep them in place. There's no point in
Yeah.
taking them out.
I guess that question applies to Ian and to Matt as well. Like electricity prices up and down. Maybe Matt first.
Mm.
You're supplying compressed air. You're not. Are you in for electricity prices as well and covering that?
No, we don't take sort of energy price risk. So obviously there can be flexibility in, what the site price of electricity or gas is, and so we can sort of toggle that up and down based on what's going on the site.
Yeah.
Yeah, same from our end. The utilities coming in are ultimately a pass through as part of the energy as a service model. So the client ultimately takes on that risk. We also recognize that often they're trying to negotiate new utility contracts throughout the course of the term. So it's just not anything that we touch.
Interesting. I think that's it. Jared,
Well,
I don't think we've
looks
missed
like
any
we
more
might have
questions.
one here from Daryl, which looks like a really good one to finish on for everybody. With the energy as a service model, overall, is the quality of the installation assets improving compared to traditional DNC, design and construct applications? Hmm. Let's put it another way. You're going to be owning and running the asset and liable for the operating costs there. Does that mean you maybe compared to when someone was buying it out, they might take a few shortcuts, get rid of that metering bit. No, I don't want that piece of heat recovery for the compressed air after cooler or something. You're going to deliver a higher quality asset. Yeah. What's our thoughts on
Yeah.
that?
Yeah, it's a definitive yes from our side because ultimately we are going to be looking to take on that risk over say a 10, 15 or 20-year term. So we recognize that the design build portion of it will probably be a higher capex and higher quality system than what would normally be put in under that traditional model. But that
Mm.
being said, the operating and maintenance costs over the long term will help pay that back. And with the right service regimen in place, especially when you take on life cycle risk, there's no question you're going to be looking to use the best materials and have the best installation you can.
I would pretty much exactly echo what Ian said there.
Brilliant. And he echoes as well.
Yeah. Yeah, absolutely. We are very incentivized to make sure the system is
Mm.
operating as well as possible.
Yeah, good. Mark, are we all done? Time to wrap up,
I think that's the case, Jared. That was an excellent session.
wasn't it? Yeah, lots of insights there. That was fabulous. So thank you so much to our speakers there. I've got from Antora, no capex, covering the design. Brilliant. And from Visi, allowing you to focus on your core business, focus on manufacturing. Probably wouldn't have had time to look at this without outsourcing this. And then coming from Ian, 10 to 20% or so savings over that period. So yeah, some really great stories. So worthy of much more consideration and diving in and reaching out to these people. And thank you all to our fabulous presentations there. So to finish off with, just quick updates of what's going on at A2EP. So we've got a next week, we're going to dive in a little bit deeper on thermal energy storage with a presentation at next week on that one. A great lineup of speakers there for you, so you can register there with that QR code or register at our events page on a2ep.org.au. A couple of member mixes coming up. Next one in Sydney next Thursday. Last one in Melbourne was fully sold out, so please register for that one. We had a full house and hopefully have a full house, no doubt, in Sydney as well. And then next month we're up to Brisbane for a member mixer up there. We've still got some slots open if someone would like to present up there. I think we've still got one or two slots open for a member to present in that one. And then finally, the coming up tomorrow, we're working with the Greenhouse Tech Hub to do this renewable heat adoption challenge, a bit of matchmaking for arena funding and what have you. It's going to be a great afternoon. So if you're in Sydney for Climate Action Week, please come and join us down at the Salesforce Tower, level 3, which is on there tomorrow. It's from 3 till 5:30. I hope you can make that. Reminder, the heat conference is on in September this year. We're starting to lock in presenters and what have you now. Lots of end user presentations. So if you've got a recommendation for us, please let us know. We're going to have lots of practical insights and lots of how to decarbonize your heating systems. As always, if you want more from A2EP, you can follow us on LinkedIn or subscribe to our e-news. Lots of great info coming out all the time. Otherwise, all that is left to say is thank you very much for joining us this afternoon. Mark, many thanks for joining me and co-hosting. Absolute pleasure to spend the afternoon with you and look forward to seeing you at our next webinar. Thank you all.